Hey everyone, and welcome back to the channel. Today, we're tackling a classic LeetCode problem, group anagrams, problem number 49. It's rated as medium difficulty, and we'll be exploring a dynamic programming approach to solve it. The challenge is simple. Given an array of strings, we need to group the anagrams together. Anagrams, as a reminder, are words or phrases formed by rearranging the letters of another word or phrase. For example, eat, tea, and ate are all anagrams of each other. The output should be a list of lists, where each inner list contains strings that are anagrams. We'll cover different approaches, starting with a less efficient one to illustrate the thinking process, and then move towards an optimized solution. Sounds exciting? Let's dive in. Understanding with examples. Let's look at some examples to solidify our understanding. Suppose we have an input array, eat, tea, tan, ate, gnat, bat. Now eat, tea, and ate are anagrams because they use the same letters. Similarly, tan and gnat are anagrams. Bat stands alone as it has no anagrams in this set. Our desired output would be a list like this: parentheses, eat, tea, ate, parentheses, parentheses, tan, gnat, parentheses, parentheses, bat, parentheses. See how each inner list contains only anagrams? Another example: input, parentheses, empty string, parentheses. Output, parentheses, parentheses, empty string, parentheses. Even an empty string is considered an anagram of itself. Let's try one more. Input, input, parentheses, a, parentheses. Output, parentheses, parentheses, a, parentheses. Understanding these different scenarios is crucial before we jump into the coding part. Got it? Great! Let's explore the solutions. Brute force approach. A brute force approach would involve comparing every string with every other string in the input array to check if they're anagrams. We could sort the characters of each string and compare the sorted strings. This works, but it's incredibly inefficient. Imagine you have n strings. You'd be making a comparison roughly n squared times. That's slow. The time complexity of this brute force method would be O of n squared, which is not ideal. The space complexity would be relatively low, as we're not creating massive extra data structures, but the runtime severely impacts its practicality for larger inputs. We need a smarter way. That's where our optimal solution comes in. Optimal solution. Our optimal approach uses a hash map to store strings and their corresponding anagrams. We'll use the sorted version of each string as the key. Because anagrams have the same letters, sorting their letters produces the same key. We iterate through the input array, sort each string, use it as a key in the hash map, and add the original string to the value list for that key. If a key already exists, we append the new string to its corresponding list. This way, we avoid redundant comparisons and significantly improve efficiency. This will change our time complexity and make it much more efficient than our brute force method. Code implementation. Let's see the code in Python. We'll use a dictionary to represent our hash map. First, we initialize an empty dictionary. Then, we iterate through the input array. For each string, we sort its characters, making it our key. If this key exists in the dictionary, we append the original string to the existing list. If not, we create a new list with the original string as the first element. Finally, we return a list of all the values in the dictionary. This algorithm is much more efficient than the brute force, giving us better time complexity. Time and space complexity. Now, let's talk about the complexity. The time complexity of our optimal solution is O of n times m log m, where n is the number of strings and m is the maximum length of a string. This comes from sorting each string. The space complexity is O of n times m in the worst case, where we might need to store all the strings in separate lists within the hash map. However, this is significantly better than our O of n squared brute force approach. We traded some space for significant time savings, a common trade-off in algorithm optimization. And that's the power of HashMap for solving this type of problem. Engagement break. So, what did you think of that solution? Let me know in the comments below. If you found this helpful, please give the video a thumbs up and subscribe to the channel for more LeetCode tutorials and coding tips. Don't forget to hit that notification bell so you don't miss out on future uploads. And if you have any questions or suggestions for future videos, leave a comment. Let's keep learning together. Thanks for watching.